Let's see, I'm Suzanne Woolf from ISC, and I'd like to introduce also Mark Schleifer, who successfully kept his name off the slides, but he's responsible for c.rootservers.net, and was also a contributor to the presentation. There are also several other root ops that are here, and if there are questions that you guys can answer, can contribute to the discussion, I would certainly encourage you to do that. And I'd also like to thank Avi for that good introduction to what we're going to talk about here, asking how many people are improving the resilience of the DNS with Anycast. ISC runs a root name server, many of you know. We've recently been doing some work on improving the availability and attack resistance of f.rootservers.net, particularly with respect to DDoS. Essentially, we're providing multiple systems behind one name and service. Anycasting a root name server has, when we first started talking about it, sounded a little radical to a lot of people. It's really not. This audience, I'm very comfortable, knows it's a natural extension of simple redundancy techniques. Now, as Avi said, as many other folks have discussed, the technology is familiar to this community, and it's a response to serious threats we're all familiar with. You know, DDoS and general situations in which network degradation between a client and a server causes problems for the user. A little bit of terminology first. We talked here about local load balancing, which many people do for many applications. Clustering often uses an appliance, you know, a specialty box. The next wider scale for that would be distributed load balancing. A lot of people do that with the DNS, NSRRs, or a single NS that is Anycast. For certain applications, people do policy-based or directed load balancing, which answers differently depending on who's asking or where they're asking from. In our shop, we call this stupid DNS tricks, which works for some applications, is not so much for ours. The thing to keep in mind for us is that the service we provide is high volume and needs to be as available as we can make it, but it's very simple. A root name server answers lots of queries to UDP port 53. It gives very simple answers to pretty much the same questions over and over and over. There's really nothing to it. There are a couple of things with local load balancing, conventional ways that we're not sure work incredibly well for us. An extra powered box may or may not handle TCP well, which is not as big a deal for us. Sometimes requires MAC address management. For us, for the kind of service we're trying to provide, for the level of sophistication we want, we just don't want to have to touch it that much. This is not the right approach for what we're trying to do. A better way uses routers and switches that are probably already in the data path. What we're doing, and the technical details are, you know, to follow, using GateD and Zebra for OSPF. We assign a single service address as an LO0 alias. OSPF does the right thing, and modern Cisco and Juniper routers do flow hash load sharing. So basically, it just works. For the local, for the IGP, this is basically what we're doing looks like. Once we have an IGP that is talking among multiple boxes, and we have the redundancy of multiple switches and routers, then we need to get it to the wider world. We have to use BGP, which is, you know, as everybody knows, sort of loosely distance vector based. There are drawbacks to this for actual load balancing, though, because geography does not equal topology, because ASs can be very big and there's no visibility provided by the AS path, and there's a certain amount of dependence on other people's policies. What we do with that to make BGP do the right thing is routes are tagged no export. FRoot only has transit at PAX and Palo Alto. Everywhere else, we scope who hears the announcement and what they do with it. This is particularly useful for all peers in an exchange point. The additional value in that is that the servers are not deep inside one provider's network. They have good visibility into a bunch of networks. And the primary value in this is it's especially useful for partitioning the impact of a DDoS. This is the big win. Once we have the internal and external routing, we also have to make sure we can manage these things. Each FROOT instance has its own AS number and its own /24 for management, completely separate from the public address and the block that we're announcing and the AS that belongs to FROOT. The 24 gets transit from multiple ISPs, advertised locally through the exchange point. This keeps attack traffic away from the management network and means that attacks can impact the local instance of the public service, but not our management. And having the exchange point fabric, plenty of bandwidth, no bottleneck there. At the moment, we are trying this out in a handful of cities, and we'll be expanding. This is not, you will not see 100 or 1,000 instances of FROOT Anycast, but we'll be in more places soon. Once we've got the partitioning of traffic that we get by doing the Anycast, there's a number of other advantages. It's easy to upgrade bandwidth anywhere. Failures are local. We get to contain those no matter what the failure is. We get to add capacity or shift load relatively easily. Plenty of bandwidth headroom, which is the critical thing certainly with denial of service attacks. And we can commit to having the service not go away for maintenance or anything else that we can foresee and provision against. We also have the advantage that we have multiple data sets, where in many cases, if you're just running a single server for a single service, you only have one place, and everything you see from the network is dictated by where you are. With distributed servers, there's a little bit more room to gather and cross-correlate data. The DNS route is served by 13 different servers, pretty much independently operated. You know, there's coordination and shared information, but everybody runs their own servers according to how best they can use what their organization and their network and their technology allows them to do to provide the service. Others, particularly since the highly publicized DDoS attack against the routes in October, everybody is looking at how to make the system more robust, and a number of folks have reached the conclusion that Anycast in some form is useful. But because diversity is one of the things that we have, you know, through the system overall, by having diverse management and diverse technology, everybody who's looking at this has their own strategy, their own analysis, their own way of doing it that capitalizes on their strengths. So, for instance, K.Rootservers is run by the RIPE NCC, the RIR for Europe, and it's a working group item for the DNS working group to come up with a detailed plan for doing Anycast with K. That's a current thing. And they're not sure when they will be doing multiple instances, but probably next year sometime. If there's anybody from the NCC here, you know, maybe they'll want to comment. C.Rootservers, Mark can talk some more about this if you know, there are questions, but C is run by Cogent, which has a large network that they control, so there are instances of C-Root in a bunch of Cogent data centers, and they're all managed by Cogent technical staff and have the high availability there. I think the VeriSign guys are gone, but J.Rootservers, which is maintained by VeriSign, has instances co-located with their GTLD servers, which of course are among the very few servers that see more traffic and more threats than the DNS route. So the provisioning that they've applied for COM, also they're using for root servers in the same data centers with separate physical facility, separate routing and switching and cross-connect. Some of the others, if anybody else wants to comment on theirs, are considering the costs and appropriate architectures for them. So it's beginning already, and you'll see a lot more this year of improved availability of root name service through these kinds of techniques. There's a few questions we hear a lot when we say, oh, we're doing this. Do we retain administrative control of the F-root servers? Can you just spin up a box and call it f.rootservers.net and start answering on that IP address? No, you can't. Yes, we retain administrative control. We run the boxes, and we work closely with the partner at the location. Have we provisioned out-of-band monitoring and troubleshooting? Yes. And we talked a little bit about that. We can talk some more if there are questions. And why not let ISPs do it? ISPs run networks. That's what they do. Well, they run the networks, and we run root name servers, including our responsibility for the integrity of the data. We're there to provide that specific service. And that's the intro. We can take some questions if you're interested further. Also, Paul Vixie is the program manager for FRoot at ISC, and you can talk to him or to me. Questions? Comments?
Daniel Diaz by PNCC. Just commenting about K, well, we are focusing first on improving encode diversity. So we have first plans to run NSD on K, and then focusing on the Anycasting. We already have the servers in 2 locations, at AM6 and Links, in Amsterdam and London. And I think it will happen this year, not next year. That's it.
Yeah, that's actually an important point. I think Avi also mentioned that another way of improving the reliability of the service is to diversify the software used to provide it. Pretty much everybody has multiple boxes. There's a diversity of operating system and network provisioning technology behind the root servers. But in addition, it will be good to have more different implementations of the DNS answering queries for the root. Anybody else? Wow. That was easy.